Now we are going to look at how to tell what type of function you have in a specific problem. So when it comes to looking at functions, you now have quite a few types to look at or that we've dealt with, and if you can tell what type of function you're dealing with, it will give you a clue as to how you need to solve each type of problem. So for today, we are going to look at if it's in an equation form and if it's in a table form. Okay, tomorrow we will look at if there's a graph or coordinates and how we can tell from there. So first off, we have example 1 and 2 have equations. Now, for the equations, what you're going to do is look at the x. So you're looking through, there's an x right there. And if I look at example 2, I have 2 of them. Okay, if you remember back in chapter 7, we talked about the degree of the polynomial or the function. The same thing goes with if you're identifying the functions. So if there's just a single x and there's no exponents, that means the highest degree is 1. Okay, so if there's no exponent, it is a linear function. Okay, so a linear function, the highest exponent is 1. Okay, so we don't even have to worry about the fact it doesn't say y equals. If we would move it to the other side, we would get still highest exponent is 1. If we look at example 2, we have an x here, we have an x here. Our highest exponent is 2, and the name for that was quadratic. So if we have an exponent of 2, it is a quadratic function. So highest exponent is 2. Now, there's going to be one other type of problem that you're going to come across, and that is exponential. Okay? So if you're given an equation and you want to know if it's exponential, what you're going to look for is an exponent of x. So it would be like 2 to the x, where x is in the exponent. So if you see x in the exponent, it's exponential. Okay, repeating, if it's just x by itself, the highest exponent is 1, it's linear. If you have an x to the 2 power, x squared, it's quadratic. If you have something to the x power, it's exponential. All right, let's look at our tables now. So the tables are a little interesting. So there's a method. You're going to have to kind of look for patterns. So in the tables, there are things called differences. What you're going to do is take the y values here, and you're going to find the difference each time. Okay? First, make sure everything here is going in order and consecutively. So -2, -1, 0, 1, 2. Everything is in a row. So now I'm going to check how each of these changes. So -3 to 0 went up by 3. 0 to 4 went up by 4. 4 to 9 went up by 5. 9 to 15 went up by 6. So now I'm going to check. If this first time here, this is called the first difference. If that first difference is all the same, so if it was like 3, 3, 3, 3, then it would be linear. It went up by a constant rate, a constant difference. Okay, here we don't see that though. It went 3, 4, 5, 6. So there is a pattern, but it's not the same thing. So if we look and we do it again, 3 to 4 went up by 1. 4 to 5 went up by 1. 5 to 6 went up by 1. So now if we notice, the second time we did it, they are all the same. This is called the second difference. So that second difference there, they are now all the same. If it happens in the second difference, that makes this function quadratic. Okay, so just like the exponent up here was a 2, if the second difference is quadratic, then, or if the second difference is constant, it's quadratic. So second difference is the same or constant. All right, so let's look at example 4. So we're going to follow the same kind of pattern or same looking. So if I notice, I'm going from here to here to here to here. Again, I'm looking at the y's. So 0.25 to 0.5 went up by 0.25. 0.25 or 0.5 to 1 went up by 0.5. 1 to 2 went up by 1. 2 to 4 up by 2. Okay, so not a constant pattern yet. So let's check again. Plus 0.25 plus 0.5 plus 1. Still not the same. But if you notice, these two are the same, these two are the same, these two are the same, so the next one's probably going to be plus 2. Okay, if you see something like this, it's not linear, it's not quadratic, so our other choice is to check if it's exponential. So if you remember back in chapter 6 when we did exponential functions, they had to multiply by a constant ratio. So we can check if we're getting multiplied by the same thing. Okay, so pick some easy numbers. So how do I go from 1 to 2? I had to multiply by 2. How did I go from 2 to 4? Multiply by 2. Half to 1, multiply by 2. All of them are multiply by 2. If you see a constant ratio where everything is multiplication, your function is going to be exponential. So it's multiplying by a constant ratio. All right. There are no practice problems officially on this. However, I want you to turn your page and I want you to look at, we're going to call this practice 1. So pause the video and try number 1 here. Okay, so first I'm going to check my constant first difference. So 12 to 4, I went down 8. 4 to 0, down 4. 0 to 6, up 6. 6 to 28, up 22. Not looking like a pattern yet. So let's try again. 8 to negative 8 to negative 4 went up 4. Negative 4 to positive 6 went up 10. 6 to 22 went up 16. Okay, so if I look here, I have 8, 4, 6, 22, no pattern. 4, 10, 16, no pattern. So now I'm going to try my exponential. So 12 to 4, I would have had to divide by 3. Remember, division and multiplication are the same. This is the same as multiplying by 1/3. But to go from 4 to 0, I would have had to multiply by 0. To go from 0 to 6, I can't multiply 0 to get 6. So I can't multiply anything either. This is a none situation. Okay, so for what we care about this year, this table shows nothing. All right. We're going to practice one of the equations. So go over to number 8. Pause the video. Write what you think it is. Okay, so again, when we're looking at an equation, we're only caring about the x's. So I have x there, x there. Look for the highest exponent. In this case, it's 2. So 2 was quadratic. So it's got a highest exponent of 2. Okay. All right, go through, try the other tables, the other equations. Tell if it is linear, exponential, quadratic, or none.